Okay, so before we get started, any questions on assignment 4? I think I extended it a few more days. I believe it's due Sunday now. And also, while we're doing administrative stuff, next week, the day before the exam on Wednesday, October 6th, office hours will be from 4 to 5 instead of 3 to 5, just because I have to go to a meeting. So it's going to be a little bit late. Okay, fair enough. Don't see any questions, but feel free to message me. I'm assuming people are going to have more time to work on it over the weekend. So today, I just really want to go over something that's not on the syllabus. I've been looking at the syllabus for like a month now and just kind of. It seems like something's missing from it, and I couldn't figure out what it was, and I finally figured it out. So I want to talk about that today. So the topic we're going to talk about today is not on the syllabus, and therefore I don't think it's going to be on the second exam. I guess they just removed it recently. I'm not really sure. But I still want to talk about it because it is important, and I think it's nice for us to talk about because I think it's easier than doing things the way that we're used to. And so that thing is exception handling. So first off, let's just talk about what an exception is. I'm sure you guys have gotten a ton of exceptions before. I know I have. And what an exception is it happens when you have an error. It's kind of a simple way to explain it. So for example, if I was to do int n equals 4 and int m equals 0, and then int, I don't know, j, we'll say, is equal to n divided by m. Then this line right here is going to throw an error, specifically an exception. And it does that because we're dividing by 0, and that's not allowed. The system doesn't know how to do that, right? And one thing to consider is that as far as the syntax of my program goes, everything looks correct. And as far as my usage of types, everything also looks correct, right? I'm using integers only. I'm dividing two integers here, which is totally legal. That's something we can do. I can also, everything's initialized. I'm setting it to a value. So as far as the compiler is concerned, this is valid code. This is totally fine. So this will compile. The compiler is totally fine with this. But when you go to run it, it doesn't work because you're dividing by 0. And, maybe the compiler can catch that. Division by 0, in this specific case, seems pretty easy to catch because I'm literally just writing the number 0 and dividing by it. But, if you're running a program and you were to read m, let's say, from the user, from cin, then, the compiler cannot actually catch the fact that there's going to be an error in your program because it doesn't happen until you actually run it and somebody gives you that bad input. And so we could error check this. We could check, if the thing that we're dividing by m is 0, then don't do the division. But assuming that we don't do that, then this is going to generate an exception. And the thing about exceptions is that compilers are not going to be able to catch them, generally. They can give you warnings about them, like this may generate an exception, and it probably will generate an exception, this is unsafe, but I can't actually catch it. So this would be a division by 0 exception. I think C++ calls it a logic error. We'll take a look at the exceptions that exist in a second. But the key thing about exceptions is they cannot be caught by the compiler. They have to be done at runtime, and they will generally cause your program to crash. So if I just ran this and I had code following this int j line, it's not going to get executed. The program is just going to crash and stop. And we want to avoid that. So we said, I could check if m equals 0 and try to handle it that way. But there's another way to handle this, and that's exception handling. And so what exception handling is it allows you to catch exceptions and then have the program not crash, at least not immediately. You can then make the program exit, but you can kind of execute some code whenever an exception happens. So I'm going to modify this really quick. Let's just go to a new thing here. Let's say I do the same sort of thing. I let m equal 4, n equals 0, and then I try to write the expression int j equals m divided by n. So I should actually probably throw this in what we're going to do here. So I'm going to write this on a separate line just because I think it's going to be nicer for our example. M divided by n. And so this is the line that generates an exception. If you think you're going to be running unsafe code that may generate an exception, then the keyword for that is try. And the word is try, and then you put braces, so you create a block. And this generates what we call a try block. And essentially what a try block is it says, let's try to execute this code. If an exception happens, then we'll execute this other code. And the other code here is called a catch. C++ is a little bit wonky about catches. I'm just going to do it this way for the time being. So there's a data type, it's a class, called an exception. And this, when we write this catch and then the exception after that, this says this will catch exceptions of this type. So if I write generic exception, then it's just going to catch all exceptions. We'll talk about the specific types of exceptions and how you can handle different ones in a little bit, but this is just kind of our general one. So what this will do is this code only gets executed if an exception occurs. So we'll just say, I guess division by 0, because we kind of have some foresight here. I'll just put a semicolon. And then you might exit the program, let's just say. So I would return 1 and stop running. So the nice thing about exception handling is that if we catch it this way, A, the program is not going to crash, but B, it just executes normally if we don't have any sort of exception. So if we, again, just say n is some variable, and then I was to do a read here instead, cin n, and try to grab n from the user, we can't really trust the user. They might want to break our program and put a 0 in there because people love to break your programs. So, you know, we could possibly get some valid input from the user, in which case this will be able to execute. We can continue our code and do whatever it is that we need to do with J later on our code. Or if the user gives us the number 0 or something else that would be potentially bad, then we'll have a way to catch it. And this is kind of similar to just doing an if check for all of this, but it's very generic. In this example, I think the only exception we could possibly have is if the user entered 0, or potentially if the stream is bad, like they just write something that's not a number, we could also have an error. But this will catch literally everything. And so you don't need to know all of the possible scenarios, you know, if this number equals 0, if the user gives me this bad input, which I have to parse and ignore and do a while loop and all that stuff. You can just kind of go, well, if something bad happens, then execute this code. And so that's exactly what this does. Okay, so that's the general gist of an exception. We can make it a little bit more specific than this. So first things first, let's talk about the types of exceptions there are, and then we'll get into more specific examples. I have an image that I am going to copy and paste off the internet. Hopefully OpenBoard's okay with it. I really don't want to write all these out. There's like 20. Let me at least pull up a list of these. I guess open board doesn't like the image for whatever reason. Okay, but here's a list I've gotten from Stack Overflow of all of the standard exceptions in C++. So we have this standard exception, and I guess I'll have to draw some of these out a little bit here. These are classes. They're types that exist. So the exception is the parent class to everything. It's just kind of like a generic exception. If you don't have an idea of what it is that you think is going to happen and be wrong with it, you should use this one. You should also use just the standard exception if you want to catch all errors. Then that's another way to do it, because pretty much every kind of exception is going to be, well, it's going to inherit from this. So it's a good way to catch it. C++ is really weird about this. Most languages, this is the base class, like everything inherits from an exception class. C++ lets you do exceptions as like integers and floats and stuff, which I'll show in a little bit, and we'll try to handle those. I'm not really a fan of that. I would suggest you don't ever write your exceptions that way, or your whatever you're throwing that way. And we'll get to what throwing means, but yeah, generally I would say check exception, but we'll do some other stuff. But we have these other ones that inherit from it. So there's like a bad allocation, a bad cast, bad exception, all these. So I think the ones that are important to us are maybe the logic error, the bad allocation, maybe out of range, and runtime. And the rest of them you can kind of just know what's up with these. So I'm sure you've encountered some of these before. I'm almost positive everybody's gotten a logic error before. Probably a runtime error, maybe an out of range error, I would assume is pretty common for everybody to hit. And that's totally fine. You know, if your program doesn't work, which it's very hard to write a working program, then you might get these. So, and we have all these different types of things. We have like bad alloc. And this one occurs when you do a bad allocation. That's not super common, but two things that I can think of would be you try to allocate memory when you're out of memory. So maybe you just have a bunch of memory leaks, or your program is consuming way too much memory and the operating system runs out. Then you're going to get a bad allocation exception thrown because it can't allocate any more memory. This might also happen if you try to use the new keyword with an array, let's just say, and I don't know, do an integer, and then you pick some ridiculously huge number that's not going to be handleable by the computer, then, you know, this also gets thrown. So keep your allocations reasonable. Don't try to take up too much memory. What were the other ones that were pretty common? Logic error, I guess, is one that you're going to encounter a lot. I think this is what C++ throws division by zero under. So these are all is a relationship. This is actually what the class hierarchy looks like. So this is division by zero and other mathematical kinds of things. C++ specifically, division by zero is only with integers will it throw it. If you try to do division by zero with floats, it just makes the number infinity, is something to note, I guess. And then I think, what was the other one? Out of range happens when you try to get something that's out of range of an array. I think if you run it on Sally, the runtime is not very helpful with that, and it'll just tell you core dump psych fault, which is not particularly helpful because it says that for pretty much everything that has to do with memory. But generally, an out of range exception is when you try to access something that's not within the range of your array, like not within the bounds. And then there's all those other types that also inherit from this, but we'll just keep it at these three for now. I'm just going to keep them in mind. So if I wanted to make that one a little bit more specific that I had earlier with the m divided by n, then what I might do is try to catch. So let's just say I already wrote all the code. Jm divided by n. I might try to catch it as a logic error rather than as just standard exception. I think it has an underscore. Let me throw that in there. One thing I think I forgot in the previous example is that there should be an ampersand after this. I don't know if I actually put it. I did. C++, again, a little bit weird with these. It takes them by reference. If you don't put it by reference, I think you get a compiler error. I don't 100% sure. I'm not 100% sure why it does that. But there we go. In this case, this will only ever happen if the specific error that occurs in the try block is a logic error. In this case, it's going to work because we're doing division by 0. And then if I was to write more code, let's just say that goes and calls some function that might also possibly cause an error when I call it, then I can do another catch for exceptions and have this catch the rest of the exceptions. Exception ampersand E. There's another way to do this that's not catching exception. If you ever just want to catch everything at any given point, then the word finally should work as well. I believe it's still finally in C++. I guess we should probably double check first. Let's try typing that up really quick. Try catch exception. Okay, does seem to be finally. Maybe not. Oh, it's purple. I don't know why. Am I missing a brace somewhere? Does it compile? No. Do I have a typo somewhere? It obviously recognizes the word finally, and that's what I'm used to. I don't know. I checked online and it seems to be what I'm writing, so I'm not 100% sure why it's not taking it. But I guess if you're ever stuck, just do what I wrote originally and just catch all exceptions. Maybe I have a typo. I'm not sure. I am almost positive it's the word finally. It's the way I've always done it, so I don't know. Some languages will let you just put catch without an exception as well instead of doing finally, but I don't think C++ does that. Yeah, there we go. That would catch all the exceptions at least. It would still potentially not catch it if it didn't throw an exception, which we'll get into, but this is generally good enough that it should catch everything. One thing to note about this is that it does go in order when you get an exception. So if this function here was to have an exception when it ran, and the exception was, let's just say, one of those bad allocation errors, then it's going to go in order and check if it matches any of those, and when it finally finds one, it's going to do it. So if it goes here, it's going to check this one, and it's going to say, is this a logic error? No, it's a bad allocation error. And then I'll go down and check the next one, and it says, is this a bad allocation error? Well, a bad allocation error is an exception, so this one, yes, we'll execute that code. This ends up being important if you try to do things in a specific order. So if instead of this, I did an exception first for my catch, you should also be allowed to put exception without any variable afterwards. You should be able to just put the type as well, although they do two different things, so I guess we'll mention that. They still catch things. And then I catch the logic error after that. If I had my try block up here that did some sort of function, and this function threw a logic error, then the code it's going to execute is going to be this one, not this one. And the reason being is because, like we did with the last example, it's going to run through one at a time and check which of these it matches. So a logic error, it's going to check, is that an exception? Yes, yes it is. So it'll never get down to this check ever, because an exception, well, a logic error is an exception. They follow each other from that class hierarchy that we had. Somewhere over here, I think. The corner. Maybe it was on this page. Yeah. We know that a logic error is a type of exception. So when it actually goes to catch this, it's going to catch it as an exception rather than as a logic error. So when you write catches, the order does matter. It checks from top to bottom. Kind of like an if-else if situation. It's really just the same. So you want to have your more specific cases at the top generally, and then your more generic ones at the bottom. So I think this would be something that makes a lot more sense, but you could certainly do this, although this code will just be useless. It will never happen. Cool. So any questions so far about our types of exceptions and how we catch them? Okay, fair enough. Just stop me if you have any questions at any point. So this is great. We can catch exceptions now. We can stop our program from crashing. But we should also be able to throw these ourselves. So if we think there's something that might be an issue, or something that the runtime system is not going to inherently catch, then we would also like the ability to throw exceptions ourselves. I want to do an example really quick of this. So let's switch over to the code really quick. Let's just leave this here. And I'm going to do, well, we need to make something first. So I'm actually going to head over. I actually went ahead and imported the matrix code from one of our last classes. So we have this whole matrix operation and all that stuff. I'm going to go to matrix.h, I guess, first. And what I'm going to do is I'm going to create a new exception class. So another nice thing about exceptions is that you can create your own types of exceptions if you really want to. And we can do that just by making a class and calling it whatever we want. So for this, what I had in mind was when you multiply two matrices, you need the inner dimensions to match in order to be able to multiply them. And you also need the dimensions to match if you're going to add them, just in general. So I can only add like a 3x3 matrix to another 3x3 matrix, and I can't do something where if it was like 3x3 and 4x3, I can't add them because I can't line them up correctly. So I was thinking of just making something called dimension mismatch, something like that. And what we can do is we can have it inherit from the exception class. And I'm just going to leave it totally blank. My only purpose of making this class is to make a distinction between the exception class and just inherit everything that it has. So I'm actually not going to expand upon it at all in my derived class here. I'm just going to leave it as it is. One other thing I think that's important to note about this is the fact that you totally can inherit from classes that already exist and that you didn't write yourself. And it's pretty common when you do software development. And so exception is just kind of like a built-in class that exists. It's in some sort of library, but I think most compilers will just include it by default. And you can actually just inherit from that class and write your own code, and that's totally fine. And so that's what I'm doing here. I have my own class that's now, it is an exception, and the only distinction is the type that it is and nothing else. It's really just going to be an exception with a different name. But let's go ahead here and implement our exception. So I'm going to go over to our matrix.cpp. And we had multiplication. I think that's going to be an easy one to do really quick. So in our multiplication, we were multiplying by two matrices, M0 and M1, and I had already written the code for this before class started whenever we were doing this, but I had checked if the columns of the first matrix didn't match the rows of the second matrix, then we had an error, and I just printed an error and returned a null matrix. You have the ability to also throw an exception, and I'm going to do that. So instead of returning a matrix, I'm going to throw a dimension mismatch. And so the way that you do exceptions is you use the word throw, and then you construct a new object of that exception class. In this case, it's called dimension mismatch. And you can give it a blank constructor. What I usually do, though, is give it a string constructor here. So I'm going to do this and say the inner dimensions do not match. Maybe we can add to this. I could like add an integer or something, but we'll just leave it like this. And I'm going to get rid of the error message then. It's going to be an error now. Is it mad that I gave it a string? Maybe I have to do it differently. I'm just going to leave it blank for now, I guess. But we have a dimension mismatch, and I can throw it. One thing to note about this is that I can completely replace my return. So if we go back to what this was originally, I had to return something, which makes sense because this is a value returning function. But now I have the ability to just throw an exception and not return anything. We talked about in CS 135, if you remember, you're forced to return a value whenever you have a value returning function, because when you write a value returning function, there's a promise that it's going to, well, return something. It needs to give back some sort of object, because whoever calls it has an expectation that there's going to be an object given back when that function is called. The one exception where you don't have to return a value from a value returning function is, no pun intended, an exception. And so we can throw this and not return anything, and that's totally fine, because if we consider what an exception does, it's either going to crash the program if they don't handle it with a try block, or if it is in a try block, then the code stopped anyways, so we don't even really need any sort of value to be returned. And that ends up being totally fine. So here I'm just going to throw something and not return anything. And whenever you throw something, it is just going to exit the function completely and work its way up and try to find any try blocks that exist wherever this thing's been called. So I'm going to now catch this dimension mismatch. Ampersand. Oh, I need to include the header for it to be able to see it. There we go. And you'll see it recognizes it, and it's able to catch these. Now really quick, I'm going to rewrite some of that code that we had originally. So I'm just going to do a matrix M0 and a matrix M1, and then I was going to read these from a file is what we had in that other program we wrote. So let me just try to get this working really quick. If stream in file open one.matrix, and then we wrote those overloads last time we did this. So I can do in file M0. Maybe I should rename these then, M1 and M2. Read to M1, then we'll close the file. And then we'll just do the same thing with the second matrix, and they should be usable now. Okay. So just as a reminder, we had two matrices, or we had like 4 matrices when we did this example maybe like a week ago. I could just reopen them really quick so we can remember what they look like. We had 2 matrices here that we're going to just deal with really quick for the sake of our examples. We have one that's a 3x2 matrix, and then we have another one that's a 2x4 matrix. And these are valid to multiply, so maybe I should actually change them a little bit. Let's make this one a 3x4 instead so that this won't work. I think, yeah, that's fine. I just need to give it one more row to make sure that the read works. Okay, so now these should read, and they shouldn't be able to be multiplied, and I'm just going to go ahead and multiply them anyways, which I shouldn't be doing. Now what we should see, because I didn't put this in a try block, is that it's going to throw my new exception. Hopefully, whenever it runs. And so if we run it, we see that the program crashes and it says unhandle exception at this address in exceptionhandling.exe. So we have that here. And it still prints the error message, and then the program just crashes. And the reason it crashes is because this isn't in any sort of try block. So let's go ahead and move it, and we'll put it in there. And then let's go ahead and just put some things here. So cout could not multiply the matrices. And then I guess we'll just kill the program if this happens. And then, I don't know, I'm going to put a exception statement here. It's just kind of generic. So if we run this, we should see that it will execute this statement, and then the program won't crash. So we see it exited exactly as it should, and it caught the exception and said could not multiply the matrices. So it's able to figure out this is the exception that happened. Now, just as an example of what we talked about earlier, let's try flipping these. And we should see that now it'll say just an exception incurred instead of doing the mismatch part. And we do. So just be careful with this. Because I had this inherit from an exception class, it is now a type of exception. And so it's going to, again, go from top to bottom and check this one doesn't match, this one doesn't match, and it's going to go in order, and if it finds one, it will execute that code. So when I throw a mismatch error when this multiplication happens, then it's going to go check this one first, and it's going to say, well, a mismatch is an exception, so this is the code to run, even though this is more specific and technically what we want, right? So just try to list these from most specific to least specific, just so that it catches it correctly. One other thing I guess to mention is you have the ability to put the type or the variable, kind of like a parameter to a function. If you just put the type, it'll just catch all the exceptions of that type. If you put a name after it, it allows you to use a variable of that exception type, so it'll just fill it in. And there is a field called what in C++. It's a function. And it didn't let me fill it in earlier. That's what I was trying to do with the string. So I'm not entirely sure what it's going to print. Probably just something generic. It just says unknown exception, which I guess is not very helpful. But d.what is supposed to give you a description of what the object, or what the exception actually was about. So it's just more detailed description. I could have swore you could just set it via the constructor by putting a string here, but it seems to not like that fact very much. I could have swore I tested this and it worked fine. You might have the ability to go into the class, I guess. where do we actually put it? In here. And in the constructor, public dimension mismatch, we just create a default constructor, and then we can say what equals, there was a dimension mismatch, but I think this is a function, so it's not going to be very happy about the fact that I'm doing this. Yeah. I don't see any relevant functions. But I know there is a way to set the string. And I could have swore it was via the constructor, but I guess it's not. So I guess we'll just leave that as is. But if you ever want to use the exception and get more details on it, you totally have the ability to do that by just throwing in a thing here. Cool. So now we can throw, now we can catch. There's one other thing we should note about throwing that's C++ specific. And again, I don't think you should ever do this. I think this is bad. At least I would argue, I just think it's really unclear to do this. Let's say I go to the matrix multiplication, and I don't know. Let's just go to the scalar multiplication, and I'll say if scalar equals 0, throw scalar. What C++ allows you to do, for whatever reason, is you can throw things that aren't exceptions. In this case, scalar is a double, and it allows me to put it here, which I think is really strange. But I'm going to go ahead and just do this really quick. So let's remove that one, put this here, and this will now call the scalar version of the function, and we should see that my program is going to crash now. And didn't. It didn't even print anything. Oh, I suppose it is because it's in a try block. Yeah, okay, fair enough. I think most languages do this anyways. If you have an exception that it doesn't know what it is, it will just keep going. So it didn't match any of these things, like dimension mismatch or exception, so it just didn't do any code whatsoever. If I do it out here, it should crash the program because it's not in the try block. It doesn't there either. Oh, because I said it had to be 0, duh. I mentioned that earlier and then forgot about it. Okay, now we see it does crash. Yeah, right? It crashes after the throw. It says right there. So it's an unhandled exception, and that was what I was expecting. And so the reason it does that is because we threw a double instead of an exception, and it will say, okay, is this a double? No. Is this a double? No. And then it sees that there's no more catches, and it says, well, I have no idea how to handle this exception, and just moves on. If you want the behavior I mentioned earlier, there should be one. Normally you do the finally. You do continue as well. Continue. No, continue doesn't work in C++. Pass is what a lot of other languages use. I don't know what word it does, but you can have it just break out of it. Nice break. Nope. I don't know. I guess you just not have code. But yeah, if you don't catch the correct exception, it's going to give you an error. So I would say never do this. Don't ever throw something that's not an exception. Some things, I guess, do that. So just be aware that other people's code might do that. And so you might have to catch other things that aren't exceptions. But I would say for programming practice, that's not good. Whatever you're throwing should be an exception. I would argue, at least. I think that makes more sense. Okay, so I think that's about everything that has to do with exceptions. We created our own exception class. We were able to throw things, catch things. I guess we should explain a little bit more why these are important. So we talked, a little bit about the fact that you can catch errors with like division by zero, and it's maybe slightly easier to do than to check if the denominator was zero and know that. In a case like that, it's kind of trivial because if you're dividing two numbers and you maybe expect there to be a zero, then you probably know in advance, well, maybe I'll have a division by zero error. But as you write more and more complex code, it becomes hard to tell if something is capable of causing an error. So if you're ever uncertain about it, I think that's a good case to put a try block, just because you can never be 100% sure what some code does. The other thing is if somebody's code, like a library, throws exceptions, you don't really have a way to error check that, at least not easily before the error happens. And I think an easy example of that I think a lot of students have encountered is S2I, which is, I think, either in string or C standard library. And I need a hash. A2I? Recognizes A2I, so I guess we'll take that. So A2I, if you remember, is a function that converts a string to an integer. If I called it like this, it would convert the number 12 to an integer data type and then return it. So I'd be able to set it like this. It's just a convenient thing for conversion. However, it doesn't work when you give it something that is not possible to be converted to an integer, like this. Can't turn that into an integer, it won't make any sense. In this case, it's out of your control. The function is going to throw an exception because you've given it something that it's not going to be able to parse, and the people who wrote this function have decided to throw an exception, which I think is fair, when they encounter an error with parsing. And so you have no control over this. There's no way to avoid the exception. And in this case, I think it's great to use a try block. So if you're ever using an external library that throws exceptions, then you should probably try a try block. Plus, this gives you a little bit of leeway with, if you don't know a whole lot about other people's codes or other libraries that you're using, then you can be a little bit more cautious and make sure that your program doesn't crash. Like now, at least, if this doesn't work, which it won't, I at least have the safety of, well, my program is not going to crash and it can at least keep running if I had more code under here. So if you ever think code is going to be unsafe, totally use a try block. It's super helpful. One other thing for just common practice stuff for this, you see I put int n here, and I kind of have separated out my other stuff. Well, I guess I didn't do it here, but in this, I wrote J. Where was the initial code? I guess it was on the last page. I wrote J outside of the try block rather than do int J equals M divided by N here. And the reason I do that is because whenever you do a try or a catch block, it does have its own scope. So if I create a new integer J here, J dies at the end of the try block, which means I can't use it any further down here. So that's why I usually do variable declarations before I'm evaluating something that I want to try at the very top, because if you do the declaration inside the try block, even if it passes and does it correctly, then all this code down here is not going to be able to work at all. Or it's not going to be able to recognize J, at least. It's not going to compile. So just for good practice, you should probably do your variables that you expect to use in a try block, declare them beforehand, unless you're intentionally doing it, you think you only need something just for a try block and then it can die. That's totally okay. Okay, so I think that about does it for try blocks now. That was kind of the main thing I wanted to talk about. And just general exception handling. So just a way to handle any code that you think is unsafe, and especially useful when you're using either other people's libraries or you're doing something like making a call to a server where it might get some sort of user data, or even reading from CN. whenever there's some sort of uncertainty, I guess, about the safeness of code, then this is good to do. Any last questions about this? And again, I don't think this is going to be on the exam, and I don't think there's going to be a homework assignment on this. It's just something that you should keep in mind for your programming. Okay, so I guess since we have some extra time, I want to talk about one last programming thing, and then we're actually totally done with C++ related stuff for the rest of the semester, which is great. The rest of this stuff is going to be conceptual. So there's one thing, again, this won't be on any sort of test, but I think it's just nice to know. There's a syntax in C++ and other languages. They usually call it for each in other languages. C++ just does for and then like a colon. If you ever have something, like let's just say a vector, which I need to include a library for, say I have a vector of integers called v, and then I push some things into it. You could traverse this the traditional way, like this. I equals 0. I less than 3, I guess, is our case here. I could say a vector.size. I think that's probably better than using a magic number. I++. And I can access things like this. And that's totally okay. There's an alternative to this in a bunch of languages that's just maybe easier when you're dealing with things that are complex, I guess I would say. And that is, you can do something like this where you say int, I don't know, I'll say number in v. And what this does is it allows you to grab every single number in the vector and have it as a separate variable. I'll just print this really quick. So what this does is it's going to say, out of all the things in v, it's going to, in each loop, set number equal to that object. And the program may have crashed from the above code. Why did it not print anything? This was caught. Oh, duh, an exception does occur. Never mind, I'm just sitting here like, why is it not getting you? So let's not kill the program when we get the exception this time. Yeah, so we see it just prints the contents of the array, or the vector. And so this syntax allows you to get things from an array and have them take on a variable instead. And it's, again, not something we are supposed to cover in this course, but it's just like a little tidbit to know. So when you do this specific syntax, num, the way I usually read this is for int num in array, let's just say vector v. When it executes, if v is whatever we had, I think it was 4820, then it creates a variable called num for the duration of your loop, and it sets it to each element in the thing. So it sets it to 4, does the whole loop, sets it to 8, does the whole loop, and then sets it to 20, and then does the whole loop, and then num dies. This is kind of nice because you don't have to worry about accessing the array with like the braces if you really don't want to. And sometimes it's just more readable. So just kind of wanted to bring it up because I know some people like doing it this way. I like doing it with things that are classes. I think is nice. But just something to keep in mind. There's another way to use this, and I think C++ supports this data type in a bunch of different places, but I suggest you never do this. I get a lot of student submissions where I think people are looking on the internet, and people on the internet love doing this. I definitely know whenever I look up C# tutorials, people love using autos. I think they're called vars in C#, but you can also use a type called an auto rather than use an integer like I had before. So I did an integer here because I wanted to declare a variable that was an integer and get it out of the v vector, which makes sense because the v vector has integers in it. If you use auto, it's going to just fill in that type with whatever the thing is. I am not a huge fan of this because if you're doing this with classes, you can't really guarantee that the thing is going to have the members of the thing, so you have to like do a cast first generally. I would highly suggest you never use auto, but it is there and it just kind of fills in the type for you. It's only in newer versions of C++ as well. I think it's like C++ 13 is the one that supports this, and this class usually does C++ 11. So I'm going to say don't ever use these, but if you see it online, like you go to Stack Overflow, that's what it means. It's just fills in the type for you. And yeah, I don't know. I would avoid using those, even though everybody online seems to love them. I don't really like it. Okay, cool. Now I think that's everything that has to do with programming. Any final questions? And I guess also on that note, we have 20 minutes left. Would you guys rather do a little bit more recursion stuff, which we'll review after the exam, or would you rather just start the review for the exam right now? Review for exam. Okay, fair enough. That's kind of what I figured. I think that's probably a good idea anyways, so we don't have to review more recursion stuff after the exam. Okay, cool. So let's talk about exam stuff. Just do a bit of a review and we'll continue on Tuesday. I put up a list of topics. You go ahead and scroll over to that. So I made an announcement the other day, I think last night, and I gave a list of topics. So let's just go through all these, maybe aside from the general C135 programming, because hopefully everybody remembers that. So the first thing was classes versus structs. Does anybody remember what the difference between a class and a struct is in C++? There's only one difference, actually. Any guesses, or does anybody remember what that was? Okay, fair enough. Don't see any responses, but a class and a struct, the only difference between them is that members are private by default in a class. If you don't put one of those labels with the private or protected or public, then it's going to assume that they're private. And the same goes for inheritance from a class. It's going to assume that you mean private unless you put the word public. And in a struct, if you don't put any sort of modifier before it, then the members are public by default. And that's really the only difference between them. They are exactly the same other than that. It's just which modifier they have by default. Let's underline that real quick. Another thing that was something we should note is that these are both examples of ADTs, which, if you remember, stands for abstract data type. And these are the only abstract data types offered in most languages, C++ included. And when we say the word abstract data type, we mean it's a custom data type that is able to take on several different forms, or it doesn't have some sort of defined behavior in the compiler, like an integer or a float or things like that, where it can just pop that straight into the CPU and it understands what it means. When we create classes and structs, we have to define the behavior ourselves. So we have to define both what kinds of things are inside of them, their variable members, and then what kind of actions they can perform, their function members. So the generic definition, for those of you who are CS majors and might take compilers, you'll hear Dr. Pedersen say a lot that these are just ways to group data and numbers. Or sorry, data and, he says methods, but we'll say functions because we're doing C++. It just allows us to put actions, being functions, and variable members together into a single package. I don't think there's any questions on it on the exam, but this is also known as aggregation. I think some people use the word encapsulation. I've seen both used. But it's just the idea that you can group things together. That's all that means. Let's see, the other topic, we had object-oriented programming design philosophies. That's a little vague, but as long as you've been kind of doing the homework assignments, I think that topic's just, that's something that you'll kind of pick up from doing that for the quiz, or for the test. We just did ADT and data aggregation, access modifiers, public, private, and protected. Let's remind ourselves what that means. Say I create a class called EX, and it's going to have a public variable called U, say integer U. I'm going to write these all on one line to keep it short so we can fit more stuff on the screen. Private variable called int I, and a protected variable called int O. And then actually, let's just throw in another thing down here. Let's say it also has a function ... We write some other stuff, and then it has a function called myfunc. And then we go and write the body somewhere else. Just say it's void returning. Okay, so there are 3 scenarios we want to consider. So let's consider myfunc, J, I, and O. We'll consider main, and then we'll do one more in a little bit. So J, I, and O. So first things first, in my function, which is an example class function, which of these variables can I access? Can I access J, I, and O, or just some combination of them? Which ones of these am I able to access in a class member function? Right, so I see 2 responses of all of them, and you guys are right. j, I, and o are totally all accessible. A public variable, if you remember, can be accessed anywhere. A private variable can be accessed only within the class, and this is within the class, so that's fine. And a protected variable can be accessed within the class and also in anything that inherits from it. So that's good. What about main? Which ones can main access here? Right, so I see public. Yeah, which is J. And what I assume you mean by that? Yeah, so I see public and J. So I assume what you both mean is that I and O are not accessible then, right? And you'd be right. So they're not. So public variables can be accessed anywhere, but the other ones can not be accessed in just a random global scope like main. So main can only access public variables. And then let's just go over to the other side, and let's say I wrote a class called ex2 that publicly inherits from ex, and then it just has something called myfunc2, I guess. Void myfunc2 takes that, and let's ask ourselves what kind of variables can be used in myfunc2 out of I, J, and O. Okay, so the first question would be, can we access J? All right, and I see a correct answer, J and I. You would be right. So it can access J and I, but not O. When we do inherited classes, then it can access things that are protected, things that are public, but not private. So our general order is private variables are the most restricted, protected variables are the next most restricted, and public are the least restricted. They're always open. And then related to this, we said that if we ever wanted to limit the way that you interact with a private variable or even a protected variable, then we have access to things called mutators and accessors, or getters and setters. And a mutator or a getter is just a function that gets something. So for example here, maybe if I wanted to be able to access that variable, I think it was called I, that was private, then I could do a function called get I, and I think a lot of people write it with a const, but not always necessary, and we just have it return I. So its sole purpose is to just go and grab something. And that was an example of a mutator or a getter. The word get there. And it's just conventional to use the word get and set when you write these. And then you can also make it so that you have a function called something like set I that takes the data type, we'll just say new I, and then sets I equal to new I. So you can do some combination of these where you limit the access to your variables and make it so that they're only accessible in some ways. So it's very common, I would argue, to only have a getter and not have a setter, and keep a variable private, and then make these functions public. That way, anybody can try to modify your code, or sorry, modify your variables by using these functions explicitly, and you can limit how they're able to do it. So I think using a get public and then having no set whatsoever is the way that most classes, I would argue, seem to go. You kind of want people to set something in your class one time, maybe via the constructor, and then just never touch it ever again. But be able to still retrieve it via get so that they can at least see the data, but not be able to overwrite it. Right, so this was our mutators and our accessors. Where is it? We got the static versus non-static scoping, which we went over last class, but we'll talk a bit about more here. Let's talk about polymorphism first, because that one's a bit shorter. So remember, polymorphism is kind of a abstract concept. It's very all-encompassing. It encompasses a lot of different things, but it was the idea that data takes on many forms. And there's no one thing that is polymorphic in any programming language. It just generally refers to concepts within a language. So for instance, we have the ability to do things like inheritance, where data can have a different form depending on whether it's a base class or a derived class. We can do things like templates, where we give a type to a function and then the compiler generates whatever the type is and the function that belongs with it, with all the types filled in. We can do things like casting, specifically upcasting and downcasting, where we have something like this, where I have like a generic animal class and, I don't know, like a cat class. I guess the arrow should probably be going the other way. And I'm able to write code that's like animal A equals cat, where I can create a cat variable and have all of the characteristics and members of a cat, but then store it in a base class variable like in animal. And this just allows us to be more generic with it and allows the data to take on multiple forms, in that it is a cat and it is also an animal. Just inheritance in general, as well as casting or keeping track of things that are of different types. And I'm sure there's a bunch of other ones that we could mention here for polymorphism. But the general concept is that data is ability to take on many forms or change forms in some way. Okay, so we want to go back to maybe static scoping. Remember, was the next thing. So we had the concept of static scope, which just means that it's separate of any sort of instance. So we had examples like this, where I had maybe a person class, and a person may have their own individual name, as well as other characteristics that define them, like their age, or maybe some sort of ID, or something like that. And then I may keep track of something that is independent of any one person, like a count of all the people that exist. When we mark a variable or a function as static, it means it doesn't need any sort of instance to exist. It just kind of is out here in the ether. And just as a reminder for the programming side of this, is that whenever you do a static variable, in order to initialize it in C++, it has to exist outside of the class for whatever reason. And you do it like this, where you give the name and then set the thing. And so we have the count out here in the static area. So we'll say static is just like the entire universe. We have the count out here. The count is static. And then if I was to go and make people, let's just say person P and person J, and pretend that I filled in their names somewhere, then we make those specific individuals or instances that exist in our universe, and they're just living in it. So we have P here, whose name might be Pierre. This whiteboard's being like awfully weird. It's like adding dots and stuff. I don't really get that. I just updated it. Maybe that's why. And then we'll say J is like Jane or something. So we have like specific instances, right? Where they're their own individuals. They are completely separate and distinct from one another. They have their own copies of things that are non-static. So Pierre has his own name, Jane has her own name. They can't access anybody's other one unless they have a reference to that person, and they're kind of like self-contained, and we can always make more if we create more instances of that class with more objects. Whereas static means that it exists only one time. It's completely independent of any kind of instance, and it's just kind of free floating. Okay, so that's what we said about that. And same thing goes for any sort of function. We can have a function that's static, which means it doesn't need to be tied to any one person. And we could also have functions that are non-static that are tied to an instance. So for instance, if I wrote a function called p.getName that just went and returned the person's name, then when I call that function, it's called only relative to that instance. So if I go and try to grab the name, then it knows about the name and everything else that Pierre might have, but nothing else about Jane or any other individual that may exist, because it only applies to itself. Now again, we can pass things by parameters or make things static and get access to other things, but just generally speaking, they only have access to themselves. Whereas if we made static functions, we can make functions that are independent of any sort of actual object. So I might have a function that belongs to the person class, but doesn't belong to any one person. It's just something that's kind of out there called maybe getCount. And this would be static. And again, in C++, they allow you to call static things non-statically, which is a little strange, but I'm just going to keep doing it this way. And when I do something like that, then it gets called out in static space, and it can't know any information about any of these individuals because it's out there in the universe and it doesn't have access to these things, unless, again, we keep some sort of static reference to them. And so we said that static things are able to access anything that's static. So if I was to call this getCount function, it can see the count because the count is static and this function is static. Therefore, they're both just existing out there in space. They can see anything. And if I call an instance function, it can see things that are within that instance. So the getName function can see the getName, and it can also see things that are static as well. We went into this in more detail in the last class. So if you need a detailed refresher, I recommend going back and watching that. And that's just kind of where we're able to use these static and non-static things. So static things you want to use if it exists really only one time. You want it to be shared between instances of a class but not belong to a single thing. And instance members are when you want it to be associated with that object. And remember that from a technical standpoint, which we won't test on, that things that are static are always just, they exist one time. They're not allocated at the same time as any object. So when I go and make a person, it doesn't generate the code for getCount or count. It doesn't store that with it. It only exists one time. And this keeps us from making a bunch of different copies of things that we don't want copies of. And really any code is static. It's not allocated along with everything else. Right. So I think that about does that for static versus non-static. And now that I look at the time, it's 6:45. So I think that's a good place to stop. Any final questions that anybody had? And on a note, I think I'm going to try to upload these images. It'll be on Canvas in the file section. Okay. I don't see any questions, so I guess we'll call it a day, and I will see you guys next week. On Tuesday, we'll do some review, and then on Thursday, we'll take the actual exam. And as always, I'll stick around a little bit if anybody has any questions.